So with this presentation, we're going to be looking at finding a problem and using mathematical concepts and formulas to find a solution. Now, first thing we're going to do is have a look at the keywords that are commonly going to be used in this, such as environmental footprint, which is basically the impact of human activity that it has on the environment. It's usually depending on what we use for our lifestyle. And then secondly, we have rainwater tank, which is basically water that's captured into a water tank, and it is used as a substitute to water from main wells. This is the process we're going to be going through to find our solution. Now the problem is, how can I lower my environmental footprint? And we're going to be looking at water and installing a water tank as our solution. Now the areas that we're going to be considering in maths is units of measurement, most likely or most commonly going to be liters since we're using water, area, number operations, formulas, tables, graphs, tallies, percentages, calculating water consumption, and finally comparing costs. Basically, our aim and objective all have to do with identifying where most of our water consumption is coming from, how we're going to utilize the water tank, where it can be located, and how, in fact, having a water tank is going to impact and reduce our water intake. Now, how do water tanks work? Rainwater is captured by gutters located on the roof or a high point, which pipes then stem down to the water tank. In some water tanks, you have filters, which captures sediments or loose minerals that aren't wanted. And then the water is stored in the tank. From that point on, people can choose whether to connect the water tank system to the household plumbing to enable water entering inside the house, or it can be used manually externally. How can the rainwater tank reduce the water bill? Since people would be relying more on the water supply from the water tank, less amount of water is used via the main water valves, hence leading to a smaller water bill. There are three main water tank sizes in Australia. You have your small, your medium, and your large. Now, determining the ideal tank size for a house, there are four things that need to be considered: the size of the residence, the number of occupants, internal and external water practices such as toilet, washing machine, the variables, and the local climatic conditions, so how often it rains, and that is according to the Department of Sustainability Australia. Now for this example, we're going to be looking at a family of four, so a medium-sized tank would be ideal. This is an example of a water bill before a water tank installation. This family is consuming 878 liters per day, and therefore their bill is getting down to $235.10. It is visible through this bill that an unnecessary amount of water is being used. This is the research of current water usage and water storage in Melbourne. As you can see, majority of the water that is collected in Melbourne is distributed to residential areas. As you can see, it's 64%. Now, where the tank will be located. As you can see by the image, we can see the size and the dimensions of this water tank. Now, when locating a space for this water tank, we found one in the house behind, at the back, next to the greenhouse garden. To find the area required, or the area that we have, the floor space, we use our area formula, length times width, which leads us to 3 by 7 meters, which is 21 meters squared, hence leading to an easy fitting location for the tank. Now we're going to look at amount of water the tank can hold. To find that, we would use our volume formula, which is pi times radius squared times height, which gives us about 8,500 liters cubed. So in a 10,000 liter tank, there is enough room allowing for a simpler overflow. Now the cost of this water tank, we would find, is roughly $1,265. Now calculating volume and capacities is acknowledged in the Australian curriculum, and it's also great for using mathematical concepts in real world. Another thing we could do is calculate the flow of water that would be entering the house or coming out of the tank. So what we could do is we could put a tap on full bolt and try to fill up a 10-liter bucket of water. Now what would happen is we would time how long it would take for that to happen. Let's say it took 90 seconds to fill a 10-liter bucket. If we were to divide that 90 seconds with the 10 liters, we would find out that it takes about 9 seconds to fill 1 liter of water, which is an ample flow of water in the household. Now we're looking at water distribution. With water distribution, we can identify which areas of the household water is most commonly used within that family. Now, according to Reyes et al., Polger's theory as well, constructing a table is a very easy way of compiling ideas and coming up with conclusions. Then we look at identifying the water distribution. And this is a process to finding the percentages of which variable is where most of the water is going to. What we would do is we would first calculate the amount of water used per variable, times it by the number of times it's used per day, and then we would divide it by the total, which is 1,308, and then times it by 100, and that would give us our percentage in total. With this pie graph, what we're then able to determine is that the washing machine and kitchen usage is where most of the household water is going to. Ways of reducing your water consumption. We're going to find this out according to our pie chart and Earth Easy. First thing we could do is we can take shorter showers, reduce the amount of water used in bathrooms, such as turning off the water once we've wet our toothbrush, using the washing machine for one full load rather than several small loads, reducing the amount of times you wash your animals in your cars per week, and also limiting the amount of water you use in watering your garden. And let the garden. Now this is a water bill after the tank installation and the usage after a significant amount of time. Already we can see a dramatic drop of water usage, such as 44 liters is used per day, and also the water bill has gone down to $96.95. Now, in comparing the water bill effects and the effect of the water tank, what we can notice is we can put two column graphs together and compare them, which is also included for the Year 6 Australian Curriculum Mathematical Guideline. Now, what we would do for liters of water used, we would simply minus the amount from the initial cost, which is $878, and then minus 44 from that, which gives us 834 liters per day being reduced. And then with the cost, you minus $96 from the $235.10, which gives us a saving of $139.10. So what we can do now is identify how long it would take to pay off the cost of the water tank, given the cost difference in the water bill. Now for that to happen, we have our two pieces of data from previously collected slide. Now what would happen is we would divide the price of the tank with the difference in the cost, and that would tell us that within 9 months or 9 water bills, we should be able to pay off the cost of the water tank. Thank you so much for listening, and I hope that you can see the dramatic change something as simple as installing a water tank can have in reducing our environmental footprint. Thank you.